Planet, named Gliese 486b, has a mass 2.8 times that of Earth. For the first time, scientists have discovered a rocky Earth-like exoplanet with a partially preserved atmosphere, giving researchers a chance to glimpse into an atmosphere of a planet outside our solar system. While a wide variety of exoplanets, made of rock, ice and gas have been discovered in the last couple of decades, studying the atmosphere of rocky planets is extremely difficult with currently available instruments. For that reason, atmospheric models for rocky planets remain untested. Researchers have now discovered a hot super-Earth in orbit around a nearby red dwarf star Gliese 486, only 26 light-years away from the Sun. The planet, named Gliese 486b, has a mass 2.8 times that of the Earth, and is only 30% bigger. It orbits its host star on a circular path every 1.5 days, at a distance of 2.5 million kilometers. In spite of being so near to its star, the planet has probably conserved part of its original atmosphere, thus becoming a good candidate to observe in more detail with the next generation of space and ground telescopes. Gliese 486b takes the same length of time to spin on its axis as to orbit its host star, so that it always has the same side facing the star. Although Gliese 486 is much fainter and cooler than the Sun, the radiation is so intense that the surface of the planet heats up to at least some 430 degrees Celsius. Because of this, the surface of Gliese 486b is probably more like the surface of Venus than that of the Earth, with a hot dry landscape and burning rivers of lava. However, unlike Venus, Gliese 486b may have a thin atmosphere. Organic matter discovered on an asteroid for the first time. Researchers have for the first time found water and organic matter on the surface of an asteroid sample returned from the inner solar system. This marks the first time that organic materials, which could have provided chemical precursors for the origin of life on Earth, have been found on an asteroid. During the Japanese space agency JAXA's first Hayabusa mission in 2010, a single grain of sample was returned to Earth from asteroid Itokawa. The sample shows that water and organic matter that originate from the asteroid itself have evolved chemically through time. The research team suggests that Itokawa has been constantly evolving over billions of years by incorporating water and organic materials from foreign extraterrestrial material, just like the Earth. In the past, the asteroid would have gone through extreme heating, dehydration and shattering. However, despite this, the asteroid came back together from the shattered fragments and rehydrated itself with water that was delivered via dust or carbon-rich meteorites. The single grain from the asteroid, nicknamed Amazon, has preserved both unheated and processed organic matter within 10 microns of distance. The organic matter that has been heated indicates that the asteroid had been heated to over 600 degrees Celsius in the past. The presence of unheated organic matter very close to it means that primitive organics arrived on the surface of Itokawa after the asteroid had cooled down.